Today I am going to explain about Markownikoff's rule and Karash effect. What is Markownikoff's rule? This rule was proposed by the Russian chemist Vladimir Markownikoff in the year 1869, and it helps us to predict the regioselectivity of the addition of protic acids to unsymmetrical alkanes. These protic acids can be represented as HX, where X represent any halogen, it may be a chlorine or bromine. How can we state this Markownikoff rule? Markownikoff rule states that when an unsymmetric reagent, that is a protic acid, adds to an unsymmetrical alkane, the positive part of the reagent goes to the carbon atom of the double bond that contains greater number of hydrogen atoms, and the negative part of the reagent goes to the carbon atom that contains less number of hydrogen atoms, that is the more substituted carbon. Why it happens? The underlying reason for Markownikoff's rule lies in the stability of the carbocation intermediate formed during the reaction. These additions generally proceed via an electrophilic addition mechanism. Mechanism primarily involves protonation. The alkene's pi electron attacks the hydrogens of the protic acid, leading to the formation of a carbocation. And the stability of the carbocation is very important while explaining the mechanism of Markownikoff addition. The reaction favors the formation of the most stable carbocation. The order of stability of carbocation is tertiary carbocation is more stable than that of secondary carbocation, and secondary carbocation is more stable than that of primary carbocation. This stability is primarily due to hyperconjugation and inductive effect, where alkyl group helps stabilize the positive charge. Once the most stable carbocation is formed, the nucleophilic halogen, that is X- ion, rapidly attacks the positively charged carbon, completing the addition. Here is an example of addition of HBr to propane. When propane reacts with hydrogen bromide, there are two possible ways the hydrogen atom can add to the double bond carbon atoms. Option 1, hydrogen adds to C2 and bromine adds to C1. This would form a primary carbocation which is less stable. And in option 2, hydrogen adds to C1 and bromine adds to C2. This forms a secondary carbocation which is more stable. According to Markownikoff's rule, the most stable secondary carbocation will be preferentially formed. So we can write the equation as CH3 CHCH2 plus HBr gives CH3 CHBr CH3. That is, the product will be 2-bromopropane. The mechanism of addition of HBr to propane takes place in two steps. Step 1 is protonation. Here, H plus ion adds to the propane. As a result of this addition, a more stable secondary carbocation is formed instead of the primary carbocation. So here the formed carbocation has the formula CH3CH plus CH3, and this is the most stable secondary carbocation. And step 2 is nucleophilic attack. Here the formed secondary carbocation reacts with Br minus ion to form the product, and obviously the product will be 2-bromopropane. The next part of this topic is Karash effect. It is otherwise known as peroxide effect, or we can call it as anti-Markownikoff's addition. And this Karash effect is an exception to Markownikoff's rule observed under specific conditions. It was discovered by M.S. Karash and F.R. Mayo in 1933. What is Karash effect? When hydrogen bromide adds to an unsymmetrical alkane in the presence of peroxide like organic peroxide, the addition occurs in an anti-Markownikoff manner. That is, the hydrogen atom of the reagent goes to the carbon atom with less number of hydrogen atoms, and the bromine atom goes to the carbon atom with more hydrogen atoms, that is the less substituted carbon. Key conditions for Karash effect. This effect is observed with HBr. HCl and HI do not exhibit this behavior because the steps in the radical mechanism are not energetically favorable for an overall anti-Markownikoff addition. For HCl, the HCl bond is too strong, making the chlorine radical addition step endothermic. For HI, the Ci bond is too weak, making the iodine radical abstraction step unendothermic. A next key condition is presence of peroxide. A small amount of peroxide is essential to initiate the free radical mechanism, and without peroxide, the reaction follows Markownikoff's addition, and there the carbocation mechanism involves. Let me explain an example for anti-Markownikoff addition. Here, addition of HBr to propene in the presence of peroxide is given. When propene reacts with hydrogen peroxide in the presence of peroxide, the product is 1 bromopropane instead of 2 bromopropane. So we can write the reaction as CH3, CHCH2 plus HBr gives CH3, CH2, CH2Br. This product will be obtained only in the presence of peroxide. So here the reaction is anti-Markownikoff addition. And the product is 1 bromopropane, that is a major product. Let me explain the mechanism also. The Karash effect proceeds via a free radical mechanism which is entirely different from the ionic or carbocation mechanism of Markownikoff rule. Mechanism of Karash effect takes place in 3 different steps. Step 1 is initiation, step 2 is bromine radical addition to propene, and step 3 is abstraction of hydrogen from HBr. Let me explain one by one. In initiation step, the peroxide homolytically cleaves under heat or light to form a highly reactive alkoxy radical. These alkoxy radicals then abstract a hydrogen from HBr to form a bromine radical. So here the products will be a bromine free radical. And in step 2, the bromine free radical adds to propene. So here there are 2 possible addition. The most stable secondary radical is preferentially formed. So if Br adds to C1, then the most stable secondary radical will be the product. If Br adds to C2, then less stable primary radical will be formed. And in step 3, alkyl radical abstract hydrogen atom from HBr to form the desired product, and here in anti-Markownikoff addition, the product is 1 bromopropane. Why it happens? Karash effect proceeds via a free radical mechanism which is entirely different from the carbocation mechanism of Markownikoff rule. In the first step, that is in the chain initiation, the peroxide homolytically cleaves under heat or light to form a highly reactive alkoxy radical. These radicals then abstract a hydrogen atom from HBr to form a bromine radical. And in propagation step, the formed bromine radical, it adds to alkene, and this is a crucial step for regioselectivity. The bromine radical adds to the carbon atom of the double bond that results in the formation of the most stable alkyl radical, and we know the stability order of alkyl radical as tertiary radical will be more stable than that of secondary, as secondary radical will be more stable than that of primary. Therefore, Br dot, that is bromine free radical, adds to the less substituted carbon of the alkene to form the more stable secondary free radical. The newly formed alkyl radical then abstract a hydrogen atom from another HBr molecule, forming the product and regenerating a new bromine radical, thus continuing the chain. So the last step is termination. The reaction stops when 2 radicals combine. So here I have given a table to compare Markownikoff addition as well as anti-Markownikoff addition. When you consider the reagents involved, in Markownikoff addition, the reagent can be HBr, HCl or HI. But in the case of anti-Markownikoff addition, the reagent can be only HBr. A prime condition for Markownikoff addition is there should not be any peroxide, And in the case of anti-Markownikoff addition, presence of peroxide is compulsory. And the mechanism, Markownikoff addition follows electrophilic addition, that is carbocation intermediate will be formed. But in the case of anti-Markownikoff addition, there involves free radical addition. And regarding the regioselectivity, in the case of Markownikoff addition, hydrogen atom goes to carbon with more number of hydrogen, and in the case of anti-Markownikoff addition, hydrogen atom goes to the carbon with less number of hydrogen atoms. So this is how we can distinguish and we can compare Markownikoff addition as well as anti-Markownikoff addition, that is Karash effect. Thank you.